All right, guys, so we've covered now exponential functions and we've covered their inverses, which are logarithmic functions, and we have a good understanding of them. We've done a couple of examples, but now what we're going to be doing is we're using both of them to kind of solve for our unknown variable. And the two main tools you're going to be using, you're going to be using other tools as well, but the major tools you'll be using to solve for a lot of these variables will be the inverse property and the one-to-one property. So remember what the one-to-one property says, that if you can get log base A of something equaling log base A of something else, then that something must equal that something else, right? So if you can match the logs, then the inside the parentheses are the same. And the same thing follows with our exponential. If I can get my base to be the same, then my exponents are also the same. Okay, and that comes from our one-to-one property. And let's look at the other one, the inverse property. We've already used these a couple of times, but I'm just reiterating here. The inverse property says that if I have a of x, a to the x, then I can use log base a of this whole thing, and it kind of undoes all of this and just leaves me with x. So the log ends up canceling out the exponential, and in the same sense, this guy, the exponential ends up canceling out the log. So that's why we call it the inverse property, right? They're kind of undoing each other. Okay, so let's go ahead. Let's look at some really basic examples, and then we'll look at word problems, which are always fun, right? Alrighty, so example 1. So we have ln, I'll zoom in, ln of x minus ln of 3, and the whole thing equals 0. And our goal here is to solve for x. Remember what ln is first. It's not important to the question, but remember what ln is. ln is equal to log base e, right? Euler's number. So right now we have log base e of x minus log base e of 3 equals 0. I think the first thing we should do is like how we solve for any unknown variable. And let's get the unknown variable by itself. So let's put everything else on the other side. So we have ln of x equal, throw everything else to the other side. So I'm going to add ln of 3 to both sides. All right. And now what I'm going to do is, well, I have this x that's trapped inside this parentheses. I need to free him, okay? So I have to undo this log, this ln or this log of base e. They're the same thing, right? So in order to undo that log base e, I have to raise both sides by e, or I have to put them in the exponent of e. Whoa, I don't know why that happened. Oh, I see. Boom, boom. Right? So if I raise both sides, if I put both sides in the exponent of e, then these two bases cancel each other out, and these two bases cancel each other out, and I get x equaling 3. Right? And what was that right there that we used? We had to use the inverse property. And which one did we use? We used the second one. Right? So we had log of e, and I raised it to e to get just that x. Hopefully that makes sense. Hopefully you can see what I just did. All right, here's the next one. I have e to the x equaling 7. Well, luckily they did most of the algebra for us. All we have to do is bring down that x. So right now I have a base of e, and I know that's an exponential function. I have to undo that exponential function to free that x. So how do I go about, I have no idea where everything just went. That was weird. Okay. So how do I undo that exponential function? I should probably use the log. And I can't just pick any log. I have to pick the log with the same base. So I'm going to pick log base e of e to the x. And whatever I do to one side, I got to do to the other side. So I did it on the left-hand side of the equal sign. Now I got to do it on the right-hand side of the equal sign. So now we see that these two bases are the same, so they kind of undo each other. So all I'm left with is x equals log base e of 7. So that's what x equals. And now some of you are like, oh wait, log base e is also just ln. So here's your first method of doing it. You can also write this solution as this. Instead of saying log base e, you can say ln of e to the x equals ln of 7. These guys will undo each other, and I'm left with x equals ln of 7. So either way, they mean the same thing. So I don't know, you guys get to pick. All right, I think you guys are starting to get the hang of this, right? So next one, we'll have ln of x equals e to the minus 3. So I have, again, log base e of x equaling minus 3. I have to get rid of this log, so I have to put it in the exponent of something with the same base, which here it will be e. So I have e raised to the log equaling whatever I do to the left side, I got to do to the right side. E raised to the minus 3. Now I have these guys will cancel out, so I'm just left with x, right, using the inverse property. And now I have, on the right-hand side, I'll have e to the minus 3. So e to the minus 3, how can we rewrite that? Well, that's e to the third, right? 1 over e to the third. Alrighty. So as you can see, we're using literally all the knowledge that we've learned in the past couple of videos all together now, just to solve for these x's. I think we got 2 more. All right. So here we have log of x equaling minus 1. Don't forget what log with no number means, right? Log with no number is the same as log base 10 of x. So really the question says log base 10 of x equals minus 1. I have to undo this log, so I'm going to put both sides in the exponent of, sorry, not e, of the same, of this base, right? So I'm going to have 10 raised to log base 10 of x. So the only way I can cancel out all of this is if my bases here are the same. That's why I chose 10 as my base for my exponential. Okay, so whatever I do to the left side, I gotta do to the right side. So I have 10 raised to the minus 1. The left hand simplifies to x, and the right hand just simplifies to 10 to the minus 1, which is equal to 1 over 10. All right, I think you guys are getting this. All right, fine, let's just do one last one. So for this last one, I gotta undo this log function. So I have log base 3 of x equaling 4. I'm gonna undo that log by putting them both in the exponent of the same base, which is 3. So I have 3 raised to log of log base 3 of x. And I'm going to have, what do I have on the other side? 3 raised to the 4. So on the left-hand side, everything cancels out except for the x. And on the right-hand side, I get 3 to the 4th, which is 9 times 9, 81. All right, so hopefully this is pretty easy for you guys, or at least if it wasn't easy at first, hopefully you guys have a better understanding of it now.